thank you guys for coming. I'm pretty excited with Scott to show you what we've been doing for the past few months. I'm Nicolas, one of the 2.5 engineers working on Stellar Core. Yes, Jed is only half. Sorry, Jed.
Wouldn't the interest in dark matter indicate that you did 95% of it?
Yes, but no. So let's see. So today what I'm going to talk about is not the first part, which is StellarD. StellarD is the code that runs the current network that we have in the Stellar network. We have a completely new stack. It's a full rewrite where we basically had a bunch of new priorities in terms of what we wanted to do. So agenda. I'm going to go basically through the goals, architecture, and give you an idea of the type of new features we have on this new network. So let's see. So what we wanted to do with the big re-architecture was to come up with something where the stack is very simple to use, so that we have an ecosystem, a rich ecosystem that kind of sprouts out of it. And as well, we wanted, with simplicity, to come with security and correctness, which are actually really hard to get when you write applications. So in terms of developer community, the low bar of entry refers to just how fast can you be up and running on the new network, on the new stack, so that we can have developers of all background really working on it, not just like experts in virtual currencies or things like that. And then we also wanted to make sure that with the new stack, we don't just have like a very narrow population of developers. We didn't just want, like on the old one, it was really addressed to C++ developers. And lastly, and that's actually the reason why we had to, or one of the big reasons we had to change the architecture, was we wanted to design something that would run for billions of accounts and thousands of transactions per second. All that without having any special hardware. So what did we do in terms of design principles? So we split what the main component into many components, actually. The one I'm talking about right now is Stellar. We call it Stellar Core. It's basically the really low-level protocol implementation. And then the rest I'll do a little bit later. But the core protocol is basically a very simple piece of software, well documented. We're aiming to have an RFC at some point, so that basically it will be highly specified in terms of how it works. And then because it's the lowest level, that's where we had to make decisions so that anything built on top of it would be correct and secure. I mean, I'll keep repeating that several times in this presentation. And then in terms of architecture, we also wanted a clear separation of responsibilities between components. Like here I mentioned historical versus real-time, because in a distributed network like that, of a virtual currency, what you have is you have also those transactions happening. And really what you do is, when you submit a transaction, is that you're submitting a transaction to the latest state of the world. But really what you're interested in later is the historical view, which is, did my transaction ever make it, or what was the result? And then you can have a proof of that result. And lastly, in terms of the design principle, we wanted something high quality and performant. So what is Stellar Core doing really? So it manages what we call the ledger chain. So a ledger, if you guys don't know what it is, it's basically the set of all entities, all entries that we have in the system. And those entities are things like accounts. So an account is like an ID and a balance, for example, things like that. We have an order book as well built into the system. So it's the state of all those things at a given time. And it's also the set of transactions that will tie this ledger to the next ledger. Because what you do is you have a ledger, you have then a set of transactions, and that allows you to mutate the ledger to a new version of the ledger. And then what Core does is it enforces invariance in the system. So invariants are things like all transactions are valid in terms of their signatures, and it also enforces that you cannot have any double spend of transactions. And also, there are many other ledger state invariants that throughout the system, such as the fact that your balance cannot be negative, or that actually it's, the balance has to be above a certain minimum. All that written as a peer-to-peer and designed for being decentralized, basically. So here I just have a very simple example of the ledger transitions I was talking about. So a ledger, in this case, I have like 3 accounts, A, B, C. They have 100, 1,000, and 5,000 as their balance. And then I have 2 transactions coming. So the first one is A sends 10 to B, and the other one is A sends 20 to C. When those together transform the ledger into the next ledger, you end up with the updated balance, and so on. So this is the very simplified version of what really the ledger is, and I'm going to go into more detail here. So here I'm repeating a bit, but the latest ledger is something where we really bias Stellar Core to work against. What I mean by that is that the goal was to make managing the current version of the ledger as efficient as possible, and make historical something that is kind of a side stream of information, but that the core doesn't really care about. And that's how we could get actually a lot of performance. So the historical data, there are actually many uses for it. Like I was saying earlier, one is for confirming transactions, but we also use it for catching up. So when catching up is basically you have a node a new node coming to the network, and is going to use the same historical data to kind of start from. And then the last one is auditing. So this one is more of a feature of any open network, is that you want the systems to be audited by all sorts of parties.
When the new node is catching up, will it read the ledger, the historical data from the transaction 1 from the beginning, or from the point where it started catching up?
Yeah, so I'm not sure. I'll repeat questions for the streaming. So the question is, when catching up, are we replaying transactions from the Genesis ledger, which is the very first one, or do we do it from some other point in time? So this is actually an option that we have, depending on the type of strictness you want to be running. So you can either replay all transactions from the beginning of time, which will probably be a problem at some point, right? Like after a few years. And we have a way to kind of download a state of ledger that is kind of close enough to to the present, then you can replay transactions from there.
So it downloads the snapshot of the ledger and then transaction history since the timestamp.
Then the transactions are tied to specific ledgers, right? So and all those are signed. Are hashed. So we can basically verify integrity. And yeah, this is actually good question, because this is actually what I'm describing here, which is the ledger chain. So the ledger chain is you have for each ledger the state, like I was saying earlier. Like for example, the ledger 1000 has those 3 accounts, and there is a transaction. Well, actually, I have to go in. Yeah, the transaction set 1000. This is basically those 2 things together. As well, where the way. I have to go back. From ledger 999, when you apply the transaction set 999, you end up in the ledger 1000. Ledger 1000 has a back pointer in terms of hashes to ledger 999 with that transaction set. So basically, that's how we can verify that when you get from the historical system, you can verify even without having the full history. You can just verify that the transition is the one that is supposed to be.
Okay, so this transaction set, is it something you introduced in this version of consensus?
No, so the transaction set was an existing concept from before. So those are not new concepts. Same with the ledger, this is the same concept. The implementation is different, but the concepts are the same.
So the whole question till the end to make it a little more cohesive.
Yeah, that's fine, but those were a good question. So here I have the kind of exploded view of how the new architecture kind of looks like from a high level. So basically what we had before was we had this big box on the left that had things like that I call the core engine, that was basically dealing with everything from consensus to the peer-to-peer system, and the storage being basically how do I store the current ledger locally. And then it was also including things like the Ledger API, which is how you communicate from the outside, from like web clients or other web services to the Stellar-D instance. And then historical APIs were things like you could get things like give me the account history for a specific account or things like that. So what we've done is break that entirely. And then we end up with this kind of really small piece here, the Stellar Core Engine, and that's the only piece in the system that is C++ at this point. So the benefits of doing this is basically that, for example, all the API code that is written is now written in web technologies. So, for example, like WebSockets is you can write your WebSocket endpoint in Node, for example, whereas before it was written in C++. So in terms of getting people to improve it is much more natural, basically. And then because the data sets are completely separate, you can build on top of those pretty easily. So in this case, for example, what I have is the historical API reads data from the historical store. And we have the built-in way we have right now of doing it is we push data into S3, but it's just a matter of getting the command line tools for whichever place you want to upload. So it could be even SCP, like you can push it to any web server. I'll keep more details on that to talk more about what kind of things you can do with those different pieces. So yeah, the Ledger API is still the same, basically getting the current state of the ledger. So current state is what is my account balance in native or in other currencies or assets that you have in the system. And it allows you as well to submit transactions to be considered for the next ledger. The historical APIs are to get the results. So the results are things like, did the payment operation succeed or not? And maybe how much fee was charged to that transaction, as well as getting the different snapshots of the history for an account. Then you have the extended APIs. So those are a little more interesting because basically they are built on top of this ephemeral data set that we kind of build. It's a kind of augmented metadata that we produce with Stellar Core. And it allows to do things like, I call it complex auditing, but those are, and Scott will talk about that later. It allows to do very detailed historical and kind of compositions of entries that are changing in the ledger. And then pathfinding is one of those other ones that you can do in that layer, because pathfinding, to make it efficient, maybe you want to take into account things like the certain trends that are happening in the system. Let's see, and I put your new ID here because. Let's see. So in terms of the rich ecosystem promise that I was talking about earlier, so at this point we do have something called Horizon, and that's what Scott is going to talk about later. And it's written in Go and Ruby. And we can see already that it's much faster to iterate on those components because you don't have all the baggage of having to deal with the C++ code base for writing basically what is a web stack. As far as the promise on secure and correct code, so what we've done is we leverage something called XDR, which is a standard specification format for serialization of data that is used for very old protocols, actually, because it's very strict. And we have that for both the input and the output of transactions. As well as any other objects actually in the ledger. But what's interesting is for the transactions, because the contract being very strict, what it means is that your code, if you write something wrong, it will just not work right away. Like there is no way for you to have like a typo and then the thing will do random stuff. I mean, it's less flexible in some way, but in terms of the core protocol, we feel confident that it's better to be very strict than be completely, have the garbage in, garbage out kind of problem. In terms of the ease of access for core developers, we have basically in terms of functionality, what we want at this point. And we are under 45,000 lines of code, and that includes tests for a lot of what it does. Whereas before it was 200,000 lines, and most of it was actually not tested. And written in C++11, so it's not too scary C++. We use lambdas and things like that. In terms of the low bar of entry for running nodes, so yeah, it's really low memory and CPU intensive, so you don't need to have like even SSDs to run it. And we also have a lot of monitoring baked into the software so that you can follow everything that it does from the outside. So as a sysadmin, it's also kind of a nice thing to have. So now I'm going to talk about new features. So what's new? So the biggest thing that we talked about in a previous dev meetup was the SCP consensus algorithm. So it's an actual implementation of the latest white paper. So that I'm not going to talk about. But yeah, like it basically allows for fully decentralized consensus. Then we have something else that that is built on top of how SCP works. That is what I call here the rich support for protocol upgrade. So basically, when the participants of the network can vote on changes to the protocol in a straightforward fashion. So a change to the protocol would be, for example, you add a new type of transaction, or you want to change the way certain, or maybe add new type of crypto in it, things like that. We have multi-sig support, and I'm going to go into detail of those. Batching, which are kind of like simple contracts. And then new asset classes that are basically like ways to hold other things than just currencies. Like before, it was just it was really easy to do things like the 4-character or 3-character currency codes, but this is kind of taking that a step further. And then we have support for federation. So I put KYC there because basically federation means you have some form of identity. So we don't do identity in Stellar Core, but it allows for people that provide identity services to provide it for people on the network. Multisig. So what is multisig? So multisig is a way to have multiple participants sign a transaction. So the way we implemented that is basically an account has a list of signers and weights. A signer is in the system now, everything is a public key. So basically the ID of an account is its public key. And the weight is just a number. And then we have a bunch of thresholds. And then what we do to do multisig is we just do the sum of the signatures we find. We take the weight that each signature has for that account. So for example, I'm going to go here. If an account has, like in this case, A10, S1 as 3, and S2, 3 as well, and a threshold of 3 for medium and 6 for high operations. So those are like a little complicated, but the type of things you can do when you have this setup is you can send a payment using any of the 3 signatures. So it's the 1 out of 3 for a payment. But you can also do things like a policy change on the account. So a policy change would be, in this case, you could either sign the policy change transaction with just the signature of A, or you could sign this operation with both S1 and S2. So a policy change is something like changing the account weights or add new signers on the account. And then finally, if the threshold for the high operation was raised to 10, which is the weight of that A signature, public key, then only A would have the right to change the policy on that account. And then we have a special name for A. It's called the master key, but that's just a detail. So batching is actually a completely new concept that we have in Stellar compared to the previous one. So what we did is we decoupled what we call transactions from operations. So an operation is something you actually do on the ledger. So it's something like a payment or create an offer being what is in the order book. And a transaction is an ordered list of operations that get applied in the order they show up in the transaction in an atomic fashion. So what that means is that if all the operations succeed, then the transaction is considered successful. If you have one of the operations that fails, all the operations side effects are rolled back, and then the transactions is considered failed. Okay, so that allows to do interesting things, especially when you combine it with multisig. So like a basic example of what you could do with this batching without multisig is, for example, if you want to go, earlier I was saying, oh, you can change the signers and so on. Well, you could imagine having one transaction that will both add a new signer and lower or change the threshold of the master key. Right? You could imagine like one transaction just doing that, and that way you don't have a time where the network is kind of in this half committed state where you have a new signer, but the weights are not exactly right. That maybe somebody can inject some bad operation in the middle and do bad things. But yeah, with multisig, you can do much more interesting things. So an example here that I have is a private exchange without a third party. So what a private exchange means is that, so in Stellar, we have this offer book thing. So that allows you to for example, put in the public book an offer for where you want to exchange some asset for another. The problem with the public order book is that anybody can really take your offer, right? I mean, you cannot just do like maybe you could say at 5 p.m. today, I'm going to put this offer and be quick, take it, right? So this allows to do basically this, but in a private fashion, so that the transaction will be submitted once to the network and be processed at once. So in this example, I have two accounts. I have an account A that wants to send an account B some credits X in exchange for credits Y. Okay. So the way you would do that, you would have a transaction that has two operations, with A sending X to B and B sending Y to A. And then what all you need to do is sign this transaction with the keys that control A and B. Okay. And if I use the example that I had earlier, I was saying that A was actually controlled for payments by either A or S1 and S2. So basically, you need one of A or S1 and S2. Actually, this is wrong. Oh no, it was any of three. So yeah, so yeah, it's A, S1, or S2. And you also need a signature by B. And then when this transaction has those two signatures, if you submit it to the network, so this can be done completely offline or through some other web service. And then you submit it to the network, and then the network will see that all the signatures are there. So then it will actually perform both operations automatically. So what's next? So we are actually really close to go and basically launch this new network. At this point, we are fixing bugs to make sure that we find bugs in software. So that's kind of the pattern we are. And because it's people start to play more and more, we are getting feedback on certain things. So we start to think about the next changes to the protocol. And one of those areas where we are starting to really think about is, are there certain things we should be doing in this layer to deal with compliance and privacy? So, yeah. And yeah, so like I was saying, the idea with this work is really to think about a family of stacks. Like I was saying, like Horizon is one branch of that stack, but I really think that we'll have many implementations depending of the stack itself with different priorities and different goals. because some people may want more logic client side so that they have like less trust in specific services and have more like the kind of the more interesting use of seeing Stellar as this network as a whole and not consider specific entities. And then there would be also probably Stellar Core alternate implementations that would expose different metadata or different data basically to the next layers. And then when you do that, then you end up also with different branches of the stack, even though the core protocol specification is still the same, of course, because everything kind of works together. Okay, so that's all I have for now. I can take questions. Yes?
Question about transactions. Is it possible to submit invalid set of or inconsistent set of operations to the Stellar Core, or what is the point of transactions that can never be invalid?
Right. Okay. So the question is it possible to submit transactions that are invalid and that will just kind of bog down the network in some way, or like spam or whatever?
No. You say that
invalid. You said
transaction will be reverted. Some of the operations will fail.
Oh, I see.
Is it possible to submit transactions with operation that you know for sure will fail? Or?
Okay, I see. So the question is really, is it possible to submit transactions where the operations are going to fail? And then, if so, what happens, right? So yeah.
Could you explain some more use cases for that?
Right. So the to answer your question on validity of a transaction, it's actually a yes and no answer. It depends on basically the type of malformed transaction you have. So for example, if you have an operation or a transaction that doesn't have enough signatures, those will be rejected by nodes as invalid right off, and they won't even make it into consensus. Then you have other trickier cases where, let's say, you have like operations that depend on each other, and you know that the dependencies are going to be bad when you actually execute them.
Okay, so
right?
Is it a way to optimize transaction size? Basically, so I don't have, instead of signing each operation with private key, I just like put 10 operations and sign all at once, like that?
You can use it for batching in the making it more efficient. Yeah.
It's a way to make it time.
Yeah.
All the operations succeed or all fail.
But yeah, to finish answering though your question on invalid transaction operations in that case, yes, they are going to be recorded if they pass all the minimum bar, basically in terms of validity, which is the account has some balance of the native currency and they're signed correctly and so on, and like the amount is not negative or bad things like that. Then it's going to be considered for consensus at consensus time, regardless of the success of the operation. We take the network takes a fee of the account.
So I guess it will be useful for exchanges between with the complex path through several currencies, right?
Yeah. So if you want to do a multi-path payment, you can either do it through offers, which is probably the order book basically, and that's automatic. Like you don't have to kind of calculate the path, or if you don't know, like in some cases you don't know exactly the path, so you know, like you want to go through like for example US dollars, but you don't know about specific issuers, then you have to pre-compute the path, and in that case, yeah, you would use something like that. Yeah.
Could you talk a bit about how you keep the ledger chain from branching?
From what?
Branching out.
Like
if two people have
Oh, I see. So the question is, how do we enforce having only one branch in the ledger chain? Yeah. So that's what the consensus is about, basically. Like it's SCP has guarantees in terms of safety. This is the safety part of the algorithm that will make it that nodes will not agree to move to a different branch, basically.
But does a node have some assurance that it's seeing the latest version of the ledger?
So everybody comes to consensus with their opinion on what the latest branch of the current version of the ledger is, right? They have a hash for that. And that's the input of consensus, as well as the transaction set. If those two things, if nodes cannot agree on even the starting point, then there will be, consensus is going to be blocked, basically. But if there's consensus on, yeah, everybody agrees on the starting point and the delta, then you can move to the next ledger.
Like conflicts handle, like supposing you're in the middle of submitting a transaction against ledger N, and the consensus session into ledger N+1. Like, do you, as a client, have to retry your transaction, or does the system?
Oh, so the question is, what happens if you submit a transaction that is not included in the next ledger? Yeah, actually, that's what the next layers in the really deal with. The whole when is my transaction validated? The short answer is you, as a client side in the stack developer, you shouldn't care about that. Like you're going to get a notification when the transaction is validated. Yeah.
Are you still using account sequence numbers? And if so, when you do a big transaction with operations affecting multiple accounts, do the sequence numbers increase in all of the accounts?
Okay, so question is, are we still using sequence numbers? And if so, what happens when we have a transaction with multiple operations?
Multiple accounts.
Yeah, and multiple accounts, yes. So yes, we still have sequence numbers, and the sequence number is only used at the transaction layer. So basically, when you have a transaction with many accounts, many operations underneath, the transaction is actually tied to a specific account, and this is the account that gets where we validate the sequence number. The other guys don't care.
In the private exchange example,
only one.
you swap directions.
Yeah, but only one of the account is going to be picked as the one where we rev the sequence number. Sequence numbers are just used for avoiding double span. So we just need one place in the entire ledger to avoid the double span. And what we do is, yeah, we have an account tied to the transaction. So it could be actually, in the case of the swap, you could imagine actually having an account C being used at the transaction layer that is only used for the sequence number. That has nothing to do with the operations underneath, because the operations are A pays to B and B pays to A, right? But you could still sign with C just to get the benefit of this other tracker, basically.
Because in the private exchange example, the last signer is a huge advantage because it will just withhold the signature till the exchange rate changes in his favor, and then submit or not submit.
Right, so that's why, I was using that as an example. But when you start to have things like that, maybe you want to have actually a C that will be kind of a neutral party that doesn't care about any of those things.
I have a remote question.
Sure.
The lab wants to know if we're going to have frozen flag in the account.
If we have frozen, okay. So the question is, do we have frozen flag on the account? And I'm pretty sure we have it already. Yeah.
Yeah. Okay.
Yes, it's already there. I'm not sure how we are doing on time.
Yeah, we should probably. Yeah. So yeah, that's great to wrap up.
Okay, well, thank you.
Nico.